This iView training video is going to focus on equipment. That's going to touch on the graphics, properties, and logic pages. Keep in mind logic pages will only appear as an option for programmable controllers. The application-specific controllers will not display logic pages. It's also going to cover changing multiple microblock properties, or global modify, checking controller status, managing set points, as well as configuring optimal start. We're going to pull in the iView interface. We are starting at the top of our tree, overlooking our building. We'll go to the floor 2 level, and here we see our familiar equipment bubbles. The area that we're going to focus on is going to be our server room. It shows us we're at 77.9 degrees, and we are red, showing this is in an alarm state. We'll select the link, and we go into our server room piece of equipment. We start out on the graphics page, and we are going to focus on graphics and properties as well as logic for this example. Schedules, alarms, trends, and reports will all be featured in other videos. On this graphic page, everything in yellow text is live data, so we can see exactly what is going on with the sensors and the outputs for this particular piece of equipment. The properties page is where we get into our control program tab. We also have tabs for I/O points, alarm sources, trend sources, network points, backnet objects, and tags. The tags, backnet objects, and network points are all pieces of the system to allow controllers to communicate across the network with each other, or also share data with other backnet systems. Our control program tab, where we start out, shows our name, a bunch of information regarding our controller address, the control program it's running, and also all of the information that we need for setting up the specifics for what this unit is going to do. More on this in a little bit. I/O points, as I mentioned, is input-output points. This is all of the physical connections to the controller. Alarm sources is where we set up all of the information of what we want to be an alarm point within the iView system, to notify us if our room temperature is getting too warm or too cold, for example. Trend sources lets us set up how we are going to record the data within the iView system. And by recording it, we can utilize that information as trends for troubleshooting and diagnostic purposes. The tab I didn't touch on, I should say, is checkout. By going to the Checkout tab, we have a place for notes that we can put in place regarding the piece of equipment. And you can use the Checkout tab to replace that clipboard hanging on the side of an air handler or boiler, for example, with some basic information keeping track of maintenance intervals and things like that. I show in this example filters being 25 by 20 by 2, and there's 6 of them. You can also put that information under the Control Program tab. Under Notes, you must have engineering privileges to be able to edit at this level within the system. So static items such as model, serial number, filter sizes, belt sizes, all of this may be something you want to put in Notes here as the building manager. Checkout can be utilized for other people within the system that maybe don't have that deep of privilege. Moving back to the graphics page, just for orientation, we looked at all of the yellow data being live. Now if we go to the logic page, we are looking inside of our controller at our control program. And again, all of the yellow text is live data. So you can utilize this page to be able to troubleshoot what's going on within your controller. If you right-click, you'll notice we have Help, Print, and Jump to. We already talked about help and print, so we'll go to jump to, and you can see that we have microblock, section, and label tabs. So you can verify what it is you want to look for in specifics. So we'll go to the section, and I want to go to my supply air temperature. I click on that. It takes me to the bottom of the screen, highlights it in yellow, and now I can scroll up to see all of my supply air temperature alarm information. For my inputs, standard inputs is right above it. I can see standard inputs and all of the information carried there. Close out of that, and we'll go back to our graphics page. From here, let's talk about being able to change multiple program or microblock properties. And we're going to touch on a couple of different aspects, both at the same time. That's going to be managing our set points, as well as changing all of our unoccupied set points within our building to be able to make the building run a little bit more efficiently if we need to. So, we are looking at our set point microblock display on the graphic. This is the graphical version of, jumping back to the logic page, this microblock. You can see it has set point depicted. It also shows our color as being red, and if we go back to our graphic page, it shows us our space temperature at 77.9 degrees is truly in the red. Rolling back a little further, that is the color that is depicted here on the equipment bubble. So let's get into changing some set points. To make any change, if I click on this and try and move around, nothing happens. I have to go into the editing mode by clicking on the arrows on either side. And now I can get into both my occupied set points, showing 68 and 74 on the green. I can see my alarm condition occurs at 77 degrees during occupied mode. You'll notice my light blue, dark blue, yellow, and orange are all depicted on the screen. And if you'll remember, that goes back to our legend that we have here. And getting back down inside of the microblock, we can see on the bottom line, or the gray conditions, our unoccupied set points, 55 and 90. From here, let's say we want to be able to change everything in the building to 62 degrees for our unoccupied set point, because we're going to have a prolonged cold snap, and 55 degrees is just going to be too hard on the building to recover. I can either go into it and type in the value that I want, or I can drag the bar back and forth to put in the value that I want, and then simply save my changes. Get that back down to the 90 that it was set at originally, hit accept, and now you can see where our unoccupied set points end up going to at 62 and 90. To be able to do this on every piece of equipment could take quite a bit of time. So I want to utilize a feature called Global Modify to change the same parameter within multiple pieces of equipment. So from this point, I'm inside of the set point editor. Again, I'm on the unoccupied set points, and I'm going to hold the Alt button down on my keyboard and click in Heating Unoccupied Set Point. That brings up our set point window. And here we can see our heating and cooling set point information for occupied and unoccupied. If I right-click on Unoccupied for heating, I have an option for Global Modify. And that Global Modify also displays a Alt-click keyboard shortcut. I'm going to select it, And this brings in our global modify window. Here we have our expression where we are looking at set points, unoccupied heating value. This is the control program that it's looking at, fan coil unit application controller, and where we are going to look. We're going to be looking in the tree under geographic location, and it is highlighted that we're going to go to the top of building 1 for all of this. So what I want to do is I want to change our unoccupied heating set points for everything. I can come here to the control program, and the notes here show us that we can use wildcards. An asterisk for multiple characters is what I want to use. So I'm going to put in an asterisk. So this is going to make me look in every control program within my system for unoccupied heating value. Now I select Find All. And I can see all of my pieces of equipment that utilize that unoccupied heating value for its operation. I do not see things in here because it doesn't apply to it, such as exhaust fan, boiler, or chiller programs. That doesn't utilize those applications. So if I want to make some adjustments, I can see my server room's at 62, 55 is what the bulk of the building is, and we have some areas at 65 and 60. Since these are variables that have already been manipulated, I could simply go to -2, change all by, actually I want to do this as +2, change all by, so I raised my set points by 2 degrees. My current values that exist inside of the controllers in the database, the new values that I'm going to load. If I decide, nah, that's not the direction I want to go with this, I want to change everything to 65 degrees, I can type that in, select Set All To, and now the new value that it's going to load goes to 65 degrees. I can now apply these changes, and it tells me Modify Process is complete. Click OK. It refreshes and now shows all of the unoccupied heating set points within my building are all at 65 degrees. Once again, that is called Global Modify. I can exit out of this. I'm going to close my set point microblock, and I can see on my display that 65 degrees that I asked it to go to. Checking a couple of other things, I'm going to go to my marketing VAV, go into the settings, and sure enough, that's at 65 degrees as well. Going back to our server room, I want to cancel out of that because I'm not making any changes. Going back to my server room to be able to manage some of the set points, I have this condition where I'm looking for 74 degrees. I happen to have this piece of equipment on a schedule that runs 24/7. More on scheduling in another video. However, as a precaution, I want to be able to make a couple of changes to things so that I don't have this piece of equipment sitting in the red on a regular basis. I can't tell if this piece of equipment, since it's in a server room, is simply a little bit undersized for the amount of load in there, or if that's a problem. So what I'm going to do is go into my set point editor, and now I'm going to, first of all, tighten up my unoccupied set points so they're much closer to my occupied conditions. In that way, in case anything ever gets upset with the schedules, it will keep those temperatures a little bit closer to normal in case something goes awry in scheduling. So I'll accept those changes. Now, I want to make an adjustment because I've talked to the folks in IT. They understand 74 is going to be hard for that equipment to get there because it is always looking for 74 degrees and almost always running around 78. And I could tell that information by looking at the trend graphs. So I am going to make an adjustment and move up my alarm to 80 degrees. I don't want it to be at 80 for my unoccupied conditions if we go out of whack. So I'm going to tighten that up. So the worst case scenario is we go to alarm when it gets above 80. If we're running above 80 degrees, we want to know about it so we can make some adjustments or get things fixed. Now I'm going to accept my change. And this reverts and shows that we are now a little ways away from being in an alarm condition. Adjusting for these conditions when your equipment is doing all that it can is perfectly normal because you want to know if it ends up approaching 81 or 82 degrees instead of seeing it in red all the time and simply disregarding the information. So that's a way that you can manage some of your set points through what we're doing. Now, for our marketing VAV B3, this piece of equipment utilizes our typical schedule in terms of on and off based upon our days of the week that we're operating. And by on and off, I simply mean we're going to be utilizing occupied set points versus unoccupied set points to be able to control the equipment. When we are in unoccupied mode, it shuts off the fans, kills ventilation, and allows our temperatures to relax and wander a bit rather than spending the dollars on energy to be able to tightly control the temperature in the space. When I utilize that type of control algorithm, which is pretty typical, I want to be able to make sure that the system is going to respond using our optimal start configuration. Optimal start allows us to set our schedule at the time that people will now be in the building, and the control system is going to utilize everything at its disposal in the mechanical systems to get our temperatures to set point by the time it goes to schedule occupied. So what that means in a little bit different context is rather than starting your building every day at 4:30 a.m. to be ready for people to be in at 6:30 or 7 because you want to give the building time to warm up, you can set your schedule to go occupied at the time that the first people start arriving at the building. So if that's at 6:30 or 7 a.m., we don't turn on all of the pieces of equipment and start ventilating the space until there are people there to make it so we have to ventilate. To make sure that's turned on within your system, on your piece of equipment, we're going to go to Properties, Control Program, Configuration, and Set Points. As we scroll down a little bit, here's our set point block information that we just discussed. Our unoccupied set points and our occupied set points. While we're here, just to touch on it, we also have Demand 1, Demand 2, and Demand 3, which is capabilities of utilizing a power meter with your iView system so you can throttle back how much cooling or heating you use based upon how much power the building is consuming, thus saving energy and preventing demand penalty charges from your utility. You can ask your iView system provider more about that complete capability. Moving on down a little bit, we have our optimal start, and we have it capable of reacting to having the building up to temperature set for 1 hour. If I want to make a change to this, I can go to this value and set it for 4 hours so that it has time to catch up. Hit accept. That will update, and you'll see it update here as well as it updates back to the controller. Then we have optimal start time, or type, Optimal start type here has no optimal start, that we're not going to use it. Temperature compensated, which means we're going to look at the outdoor air conditions, we're going to look at the indoor conditions, and we are going to look at the set point and how much time it's going to have before it gets to that occupied start. And then we also have learning adaptive, which learning adaptive has some more parameters that you can set here to be able to let your system learn how long it takes for the system to warm up or cool down. For this example, we're simply going to use the default values of 15 that are in place for the heat start K factor, cool start K factor. And we're going to leave this at temperature compensated. So this is going to allow this piece of equipment to be able to start up to 4 hours in advance of going schedule occupied, to be able to get our temperature up to our occupied set point from our unoccupied set point that we are running at. Once you have this in place, your building will be able to make adjustments on its own in negating that need for you to have to spend time starting the system up a couple hours early to be ready for the day. One last thing we're going to touch on while we are in this area under equipment is equipment status. So we're going to go to the installer level, and we can go to devices, and we'll expand down to our router. And the router has all of the pieces of equipment connected underneath it. And this is showing us the status of all of the controllers underneath the router. And we can see download schedule is needed on a lot of these. If I go to the downloads button and expand it, I can see that I had communications failures when I changed schedules. I created this example so that I would have something to show you for this exercise. I'm simply going to hit start. It shows us that we have 2 downloads pending. And just that quickly, we were able to push the schedules down. If I go back to devices, I can see check marks for the status on everything. Our upload all content under controller 127 is on a device that does not upload. It is a touch view.